MAT1033 Final Exam Review Question 44. We are to factor completely. We have 3x squared y minus 27y. We start with the GCF. The GCF is 3y, so we're going to factor that out. We end up with 3y times the quantity x squared minus 9. And remember, we have to factor completely, and this is a difference of squares. So we're going to have 3y as one of the factors, and then x squared minus 9 would be x and x, 3 and 3, minus 3 plus 3. That should be the factored form of the original polynomial. MAT1033 Final Exam Review Question number 45. I'm to factor completely. I have xy minus 3y minus 2x plus 6. I start with the GCF. GCF is 1. I have a 4-term polynomial, so I'm going to factor by grouping, and I'll group them first 2 grouped, second 2 grouped, and then take out the GCF by groups. So if I take out a y out of the first set, I have y times quantity x minus 3, and the second set of terms has a 2 in common, but it's either going to be minus 2 or plus 2. So I'm going to go ahead and take the negative out with the 2. So this is going to be y times quantity x minus 3 minus 2 times x minus 3. 6 divided by negative 2 is negative 3. So that's going to give me 2 terms instead of 4. So they're still terms. It's not factored. But if I look at the 2 terms, do you notice that there is a common factor of x minus 3? And if I factor that out of those 2 terms, I end up with x minus 3 times the quantity y minus 2. If you multiply those 2 binomials together, you'll get the 4-term polynomial we started with. MAT1033 Final Exam Review Question number 46. We are to factor completely, and we have x squared. Oops, wouldn't be x squared. How about x to the 6th? X to the 6th plus 27. Okay. We start with the GCF. The GCF is 1. It's a binomial, and the only binomial that we can factor that's a sum is a sum of cubes. And let's refresh our memory on the factored form. A cubed plus b cubed. And remember, we worked with this earlier in the semester. A plus b, a squared minus ab plus b squared is the factored form of a sum of cubes. You can verify that by multiplying those together, and you'll see that you'll get that binomial. Okay, so what I've got to determine is what was raised to the 3rd power for each one of these terms in order to find the base that I would substitute in for a and b. So if we think about our exponent rules, raising a power to a power, you multiply. So this is x squared to the 3rd, gives us x to the 6th, and then if you do the factor tree for 27, you'll see that 3 to the 3rd is 27. So where there's an a, I'm going to put x squared, and where there's a b, I'm going to put 3. So the factored form, I'm going to have a binomial and a trinomial, and I'm going to have a plus b, so x squared plus 3, the 2 bases, and then I want to square a, so whatever I put in the first position, I square it. X squared squared. Okay, and then minus x squared times 3, and then plus 3 squared. And if I clean that up a little bit here, it's x squared plus 3, then this is x to the 4th, minus 3x squared, plus 9, and that's the factored form of the original binomial. That's the factored form.